Hello friends, for our BSc program in Geography, we have a course on the elements of physical geography in which we have a block on atmosphere. So you are already aware of the processes that lead to extreme weather events like thunderstorms, cyclones, fog, heat and cold waves, etc. So the topic of today's program is predicting weather, and for this we have in our studio Dr. L.S. Rathore, who is the Director General of India Meteorological Department, Government of India. In the previous part of this program, we emphasized more on the observation and monitoring skills of IMD, and in this program, we would be covering on the prediction skills of IMD with reference to extreme weather events. Over to you, Dr. Rathore.
Dhanyavad, namaskar. Predicting weather is one of the challenging problem in science, because in weather you deal with uncertainty which is caused because of chaotic nature of atmosphere. Atmosphere is such a complex phenomena, it never remains stationary, it changes every second, every minute, every hour, and when you deal with prediction, you have to capture that uncertainty. And in this talk, I would just touch upon that and also touch upon as to what are the limits of predictions, to what extent atmosphere is predictable, and what is the current level of skill in tropics particularly for various phenomena and the predictability. When we talk of prediction, we always talk science based prediction systems, and that therefore has to be an objective process of prediction. As we have understood that first you define the initial state of atmosphere through observing systems, and having done that you are assimilating those data, and this assimilation cycle is very complex, because when you run the model, you run twice a day, maybe 0 universal time coordinate UTC and 12 UTC, but constantly, since atmosphere is changing both in time and space, from over the globe you are assimilating information every 3 hourly to understand the processes which are happening in the atmosphere, which are attributed to the change which are happening, and thereafter you embark upon issuing the forecast. So, in the process you observe the data, collect at a regional telecommunication hub and generate a kind of assimilation system, and then you run the model. Now, this model run is a very complex situation. The current methods which are deployed in the developed and developing nations for predicting weather is numerical weather prediction techniques. When we talk of prediction in different temporal ranges, the methods which are deployed or tools or models which are deployed for predicting in different temporal range are different. For example, when you talk about nowcasting, which is only for less than 12 hours, then you deploy different models, because here the spatial resolution you are talking is very small. In short and medium range, that is up to say 10 days, you deploy different types of numerical models. When you go beyond 10 days, that is extended range up to say 1 month, you deploy different types of model. When you talk in terms of seasonal scale, you deploy different models, and when you go in climate scale, you have a different models. For medium range, currently we are deploying global forecasting system, which is called GFS, and this is the name of the model T574L64, meaning which that there are 574 waves engirdling the entire globe, and that would mean that at the horizontal grid resolution of about 23 kilometer, and levels are 64, that is vertical levels of atmosphere are 64, and we are running these model twice a day, 0 universal time coordinate and 12 UTC. But unfortunately, no model is able to perform good all the time at all the space. And we have a global franchisee with all the advanced numerical weather prediction centers who are running global models, which include India, Japan, Korea, China, then European Center, America, Australia. And we are sharing our model output, and through that we are generating multi-model ensemble, and that is being deployed for medium range weather forecast system. For short range forecast, we are deploying at a much better grid resolution, and for that we are deploying different models which we call as weather research forecast model, and that is currently being run at 9 kilometer resolution. We also have 3 kilometer resolution model and 1 kilometer resolution for various applications, like when we give stadia specific forecast for certain sports activity, we do that at 3 and 1 kilometer resolution. For cyclone, we do hurricane weather research forecast model, and we have done different tools and models which are addressing to the forecast needs for polar regions, because we have stations in Antarctica and also we operate in Arctic region. For that we are deploying different models. But nowcast, which we have started a year ago, is a different ball game, and nowcast is to be done primarily taking stock of the current weather situations, which is monitored by radars, and therefore you see, you observe and monitor various weather conditions through radars, identify if there is a threatening weather situations, assimilate that data which are generated by the radar into model and generate the forecast, and also to communicate, and that has to be done in a very faster mode. But as I mentioned, that models do not have desired skill, or rather I put it in a different form, that there is significant improvement possible by human intervention. You do not take the model output directly as the gospel, and we do make use of global GIS and other tools to see different layers of the meteorological products to assess the likely impact on generation, or rather likely impacts on the processes yielding certain type of weather events, and ultimately generate the forecast. Now, the current status is that for homogeneous zones like monsoon forecast, we cannot give for New Delhi how the monsoon is likely to be. For that we give country as a whole, all India one figure, and the 4 homogeneous zones. So, also if we talk in monthly scales, we cannot be highly locale specific. But when it comes to the medium range forecast, or if we are to address meteorological subdivision and special domains lesser than that, then we give forecast up to 7 days, and for block level, each district now there are about dozen blocks, then the skill is only available 3 days. And therefore, the applications which are required to be developed has to attune themselves to the limits of the prediction for various forecast. Currently, we are generating a host of forecast bulletins. We are generating all India bulletin, regional bulletin, state level bulletins 4 times a day. Every 6 hourly we are updating these forecasts. The district level forecast, which is primarily generated for farmers, are generated twice a week. Cyclone prediction we are generating 3 hourly, but when cyclone come closer to the coast, we are issuing hourly bulletins. Then aviation forecast. Aviation is a very critical and we have to generate every half hourly forecast, because there you are operating in a very small time window. Then hydromet forecast twice a day, marine forecast 6 hourly, city forecast once a day tourist forecast, highway forecast, forecast for Antarctica, air quality forecast. This we are doing for Delhi, Pune, and now we are going to launch for Bombay. Then nowcast, which has to be done hourly, and there is a demand for half hourly nowcast, which has to be highly localized, and then extended and seasonal range forecasts. There are some new initiative which we have taken in the last couple of years, and now we are generating forecast up to 20 days, and for each pentad 5 days, second pentad, third pentad, and fourth pentad. And this is the kind of forecast which is very useful in addressing, or rather capturing, the active and break cycles of the monsoon, because during monsoon, apart from local specific precipitation forecast, user need as to how long, if there is a dry spell, the dry spell would like to continue, or wet spell, and when it is likely to break, and the change of spell cycle takes place, and that is the kind of product we are generating. The cyclone forecast is most critical, and there are 3 aspects of cyclone forecast. And before you embark upon forecast, as I mentioned, for any forecast you have to take stock of the current state of atmosphere, and in the context of cyclone you need to characterize the cyclone and also identify as to where it is located and what is the current intensity of the cyclone. That is the first challenge, and you do not have large number of observations when cyclone is deep into the ocean, high into the ocean, and therefore you have to solely depend on the satellite based observations with selected oceanic observations which are available at your command. And then you have to embark upon predicting in which direction it is likely to move and with what speed it is likely to move. So, therefore, the track and intensity forecast is very critical, and also you have to generate at what time it is likely to have landfall and what place it is likely to have landfall. And when it come closer to the coast, then we have to give the scenario of precipitation, wind, and also the storm surge, which is a bigger killer than both precipitation and wind, because it is not uniform, because cyclone has thousands of severe clouds, thunderstorms which are embedded into it, and it has a vast area of about 500, 600, 700 kilometers, and it is not one system. It will have large number of bands, and therefore, when it cross the coast, there is a large fluctuation in precipitation, wind field, and the storm surge. So, therefore, you have to take a holistic view to generate that kind of forecast, and that is really very challenging. In order to address that challenge, we have a 5-step process. Then of course, we run the numerical weather prediction models, you take stock of the model output, and then further process these information to generate various parameters which are, or characters which are related to the cyclone. Even before cyclone is formed, you have to generate what is the potential of cyclogenesis. So, whenever there is intense cloud in the ocean, we are watchful, and we then run the models. We have developed the models which are able to give the genesis potential parameters, and therefore, you might have noticed now that now we give well in advance that cyclone is likely to form. This was not earlier. Then at the second stage, we have track prediction models which are indigenously developed, intensity prediction models which are again indigenously developed, and in case of Pelin, which you mentioned, the Pelin rapidly intensified between 10th and 11th of October 2013, and that was very well predicted. And most of the models, when they come closer to the coast, they lose their shine for various reasons, like the recent cyclone Nilofer or Madi or Leher, and these cyclones. Therefore, the decay forecast is equally important, because at times the cyclones are more devastating in nature after they come onto the mainland, because they sustain for a long time and have a great potential to give continued precipitation over a wide spread region, causing damage to crops and causing the floods. This is the warning which was generated for cyclone Pelin for different temporal range. This is the kind of error structure which is available, very good. This is, as a matter of fact, a world record kind of just error of 3 kilometer at landfall point and the landfall time of 3 hours. This is for Hudhud, and this is what we because when you give the forecast, you also give the cone of uncertainty, because when you are giving a track, you also factor into, because cyclone do not move straight, it move like this, and when it is moving, at times it is quite disturbing to the forecaster, because there is a tendency to see as to how it has moved in the last 6 hours or 12 hours. So, you should not be carried away with that, and duly analyze the model output in understanding the future tracks, and therefore, the use of this track prediction models is very critical in giving the forecast related to cyclone tracks. The storm surge and the coastal inundation is a very complex process, because when cyclone come with the strong winds or the force of winds, the oceanic water which is liquid is also pushed and cause lot of waves, and it will create a surge. But surge, therefore, it not only depends on the speed of winds which is associated with cyclone, but what is the kind of bathymetry. If the bathymetry is shallow, the surge and the inundation is higher. Also, the topography beyond the coast, if the topography is steep, water is not allowed to penetrate further into the coast, and so therefore, you need to factor into all these factors and model them into a very comprehensive system to give forecast for storm surge. And presently, we are able to give forecast which is also done in association with INCOIS and IIT Delhi, and we are giving forecast up to what meters the sea water is likely to inundate, and that is very useful for taking precautionary measures. Thunderstorm, which is again a very killer weather system. As a matter of fact, more deaths are happening because of thunderstorms than cyclones, because of lightning and squall and heavy rainfall. This is highly challenging to predict the thunderstorm. Basically, we embark upon predicting the thunderstorm which is caused by the instability in the atmosphere. Both northwest India and the East India, where they are locally called as Kal Baisakis, are the seats of intense thunderstorms. Of course, they occur everywhere in our country, but we therefore need to identify as to what is the cause of instability which triggers to the formation of thunderstorms. And this is a very complex situation, and we need to, because instability, though it is primarily triggered by the radiative heating, but the local topography and the heating and the land surface process add fuel to the fire. And when it comes to the mountainous region, particularly the Himalayan region, which is having a steep rising motion, if the wind is coming from a particular direction, and that accentuate the instability process, and at times we notice that heavy rainfall events leading to intense precipitation over the mountainous region are triggered. So, the thunderstorm forecast is primarily dependent on the Doppler weather radar observations, and these radar observations are immediately assimilated into the models. The forecast is immediately put on to the dissemination process, and we are putting on the web page. The protocol of forecast dissemination is equally important. So, the warning generation has a various component, and most important is that you have to have a standard operating process protocol in place, because you have a shift of 8 hours and the next person will change, and therefore, there should not be any digression from what the earlier person was doing, and therefore, you have a standard protocol which is addressing this, and the warning elements for cyclone it is different, for heavy rainfall it is different, for thunderstorm it is different, for strong winds, for temperature both the cold wave and heat wave it is different, and I will just address that. These are the way we are presenting our warnings as of now. Different meteorological subdivisions are reflected both in terms of this is the forecast and this is warning, and different color codings are provided for different days. Presently warnings are being given only up to 3 days. This is the warning protocol for heat waves, and we know as to how to define the heat wave. That also is very critical, because one should be able to comprehend when the department says heat wave, what does it mean. So, if it is 5 to 6 degree above normal temperature, then it is heat wave, and there are different temperature range which defines severe and very severe heat wave and so on and so forth. So, this is also for cold wave and visibility and ground frost, which is very critical for crops, and for that we have a different types of bulletins, because each bulletin has to address the requirement of each user, and therefore, you need to address through different formats of the forecast which is to be addressed into the bulletins which are then issued along with the warnings. Now, coming to the skill, till about 3 years ago we were running a different type of model, and that model has this kind of skill in terms of correlation coefficients. I am just giving a just broad overview, and we changed from that was the model at T 382 at a horizontal grid resolution of about 36 kilometers. And when we switched the gear from T 382 to 574, which is the current model, there is a tremendous jump, and now we are likely to embark upon next generation model, and I am sure the graph would be here in a couple of years from now. The local rainfall forecast, there is a tremendous improvement. So, if I give a overview, the heavy rainfall warning is the most challenging, and the current skill of heavy rainfall warning is 88%, and that is the percent correct forecast, and probability of detection is 73%, critical success index 58%. The false alarm rate is only 8%. That is really very significant. Fog we have started forecast couple of years ago, and this is the kind of accuracy above 90%, and we have planned that earlier the large number of aircrafts used to be diverted, and when aircraft is to be diverted beforehand, it has to carry that much of fuel, and then it is a highly expensive process. This is the kind of improvement in the number of flights which are diverted over the years, which is significant improvement, and aviation sector is very happy with us. This is just to give a glimpse of the improvement in the track forecast from 2009 onwards. So, significant improvement. This is improvement in the landfall point, see, significant improvement, and the last cyclones you see the red one is predicted and one is observed track. It is almost and this is I am talking 5 days in advance, 5-day forecast. So much, and the biggest challenge was this, which was moving northward, recurved and came to Tamil Nadu coast, and right at this point we warned the Tamil Nadu state government that it is likely to recurve and come here, and it was very severe cyclonic storm like Pelin, and the government was very worried, but we said no, it will weaken when it will come here. I failed to predict present the track of Nilofer. Again we told the government of Gujarat that it is likely to weaken, no evacuation, no measures are required to be taken. So, that is the kind of performance improvement which has occurred. Important is not only forecast, but as to how you discuss and take along the stakeholders, and one of the stakeholders is the reservoir managers, because most deaths occur after the landfall of the cyclone because of the heavy rainfall and the flood situations which are encountered because of or triggered because of the release of water from the reservoirs. And during Pelin as well as Hudhud, we are now in a constant dialogue with the reservoir managers, the governments, so that water is released beforehand. Confidence in our forecast is such that during Pelin, I was so confident it took me 1 hour to get the gate open, but during Hudhud it was only 12 minutes gates were open. Monsoon 2014 was again very challenging. April forecast we gave that 93%, which was later revised to the deficiency of 13%, that monsoon will be 87% of the long period average. Onset of the monsoon is very critical. We are issuing forecast, and which is very correct now. In the last many years we are able to give a correct onset forecast. Now improvement, as I mentioned, will have to come through minimizing errors through improved and smart observing systems. Data assimilation is very critical, because you have to filter the data, because there is a huge error in the data, and if that erroneous data goes into your model, it will do more harm than good, and therefore, we are doing a lot of exercise in assimilating and filtering out the erroneous data, and then lot of R&D work which is now going on, particularly to understand the monsoon and also the impact of mountainous and particularly the Himalayan region in the general circulation over the region and globe as a whole, to further improve the weather forecast. Thank you very much.
So friends, after viewing this program, we are now aware of the importance of different temporal ranges of weather forecast like long range, medium range, short range and a very short range, which is also called nowcast. We are also aware of different aspects of cyclone forecasting like its genesis, its track and intensity prediction, different aspects of thunderstorm forecasting and other extreme weather events forecasting. You have also learnt about the improvement in the prediction skills of IMD over a period of time. For any further queries, suggestions and feedback, please write to us at the following email address satyaraj@ignou.ac.in. Thank you.